This is the last set of formulas you're going to learn. And if you notice, they're called double angle identities. In this lesson, we will derive identities for sine of 2 theta, cosine of 2 theta, and tangent of 2 theta by using the sum identities that we learned in a previous lesson. Now, let me show you what I'm talking about. There is a formula for sine of 2 theta. And the first thing we've got to do is figure out what the formula is, and you're going to see where it comes from. I know theta plus theta is 2 theta, right? So what I'm going to do is I'm going to rewrite this as sine of theta plus theta. Oh, but I know a formula. I know that the sine of u plus v is sine u cosine v plus cosine u sine v. So I'm going to use that formula. Now, what would have to go in place of u? Theta. And what would have to go in place of v? Theta. So this is going to be sine theta cosine theta plus cosine theta sine theta. What do you see there? There, I got 2 of them, right? I got 2 of the same thing. So this is 2 sine theta cosine theta. So the formula for sine of 2 theta is 2 sine theta cosine theta. Double angle identity for cosine. Well, I know that the cosine of 2 theta would be the same as the cosine of theta plus theta. I'm going to go down here and I'm going to write the formula for cosine with a plus. Cosine of u plus v is cosine u cosine v minus sine u sine v. Well, what am I going to put in place of u? Theta. And what am I going to put in place of v? Theta. So this is, and by the way, don't write great big here. Don't take up the whole box because you notice it's a big box and there's a reason for that. So this is cosine theta minus sine theta sine theta. With me? What is cosine theta times cosine theta? Cosine squared theta. So this is cosine squared theta minus sine squared theta. That is one of the formulas. What do you mean one of? I mean one of. That's one of the formulas for cosine 2 theta. You say, well, crap, that means I got more? Yep. Now, let's think about the big kahuna. Remember, big kahuna says cosine squared theta plus sine squared theta equals 1. What is a substitution I could make for cosine squared theta? 1 minus sine squared theta. Good. If I subtract sine squared theta from both sides of this, I get cosine squared theta equals 1 minus sine squared theta. So in place of cosine squared theta, I'm going to substitute 1 minus sine squared theta. And then the rest of the original, or the previous formula. So what's that? Well, that's 1 minus 2 sine squared theta. So that's another way that you can write a formula for cosine of 2 theta. Here's one more. And you might be able to guess how to do it. You're going to take, can you make a substitution for this sine squared theta from the kahuna family? What would it be? 1 minus cosine squared theta. Good. So I'm going to take this formula right here, and I'm going to write down the original cosine squared theta that came first minus, now sine squared theta is 1 minus cosine squared theta. Why do I have that in parentheses? Good, because I'm subtracting the whole thing, so I have to distribute that -1. Now, if I distribute that -1, I'm going to go over here and write this so that I can save some room. That's going to be cosine squared theta minus 1 plus cosine squared theta. What do you get? Simplify, combine like terms. Yep, and we're going to just write it like this. 2 cosine squared theta minus 1. Those, ladies and gentlemen, are the 3 different formulas that you could use for cosine 2 theta. And you say, well, fiddle, why do I need 3? Well, because sometimes only one of these is going to help you in your work. We'll get to that in a little bit. All right, double angle identity for tangent. Tangent of 2 theta is the tangent of theta plus theta. Well, now let's go down here and let's remember what the original formula was. Tangent of u plus v was tangent u plus tangent v divided by 1 minus tangent u tangent v. You know the routine. What am I going to substitute in for u? Theta. What am I going to substitute in for v? Theta. So this is going to give me tangent theta plus tangent theta over 1 minus tangent theta times tangent theta. Now we're just going to clean that up a little bit. Numerator, 2 tangent theta over, good, 1 minus tangent squared theta. Ladies and gentlemen, all we're going to do the rest of the lesson is work with those 3 formulas. Those formulas will be on your quiz. Here we go. Suppose the sine of theta is -3/5 and the tangent of theta is positive. Answer the following questions about theta. A. You good? Go ahead. Go ahead. In what quadrant does theta terminate? Your sine is negative. 3 and 4. Your tangent is positive. Say again? 1 and 3. What quadrant does this angle terminate in? Quadrant 3. Now let's go to part B. Draw the angle theta and label the reference triangle. Are you good with that being your reference triangle in terms of location? Sir? You mean the rotation could be the other direction? Yeah, it absolutely could. It absolutely could. We just go with positive unless we're told otherwise. We're told that the sine is -3/5. What goes where in numbers? Good. -3 is here. Good. 4, but why is it negative? Because it goes to the left. Good direction. Way to go. Well, fiddle. All right, we got the B part done. Now C, order sine of 2 theta, cosine 2 theta, and tangent 2 theta from least to greatest. Well, that means we got to go find them. Sine 2 theta. Now I want you to notice this. I don't know what theta is. I don't care. I don't need to know what theta is. I need to know what the sine of 2 theta is. And I can find that without actually calculating the angle measure. You with me there? Okay. Sine of 2 theta. Remember the sine of 2 theta. Remember the formula? What's the formula? Perfect. And we're going to pull sine theta and cosine theta right off that triangle. 2 times. What's the sine of theta? Negative 3/5. Good. Times the cosine of theta. What's the cosine of theta? Perfect. Negative 4/5. Multiply. What are you going to get? Say again? Well, 24/25. Yeah. Questions there? Now you're going to remember that. I'm going to have to erase, otherwise I won't have any room. So we know the sine of 2 theta is 24/25. Cosine 2 theta. I got 3 different formulas. How do I know which formula to use? In a case like this, it doesn't matter squat which formula I use. I can pick any one of them. You pick the one you want to use. I'm going to pick the first one, cosine squared theta minus sine squared theta. But you use any one you want, you're going to get the same answer because those are all identities. Cosine of theta, you said was, so that's negative 4/5 squared minus, what's the sine of theta? You said negative 3/5 squared. What do you get? 16/25, good. Minus 9/25, good. Equals 7/25. Yep. 7/25. Again, I'm going to erase so that I have room. You should have plenty of room. Let's do tangent. Tangent of 2 theta equals, good, good. Now the nice thing is tangent theta is right on that triangle. What's the tangent of theta? Come on, what's the tangent of theta? 3/4, opposite over adjacent, 3/4. So this is 2 times 3/4 over 1 minus what? Perfect, 3/4 squared. Remember when a problem looking like that would scare you to death? Not this year, but like in previous life? Still scares you to death, huh? What's 2 times 3/4? 6/4 is 9/4. 6/4 or 3/2. And then the denominator is 1 minus 9/16. How do we do that? By the okay. Look at the question. Order sine 2 theta, cosine 2 theta, tangent 2 theta from smallest to biggest. What was the smallest of those three? 7/25, which was what? All right. Which one was next? Sine 2 theta, that was the 24/25. And then, because that's bigger than 1. Well done. Questions? Pretty easy. All right. Verify that this thing's an identity. Given the section that we're working on, which side do you think we probably need to work on first? The one that's got 2 theta in it? You're saying, well, student, we didn't do a cotangent. No, we didn't, but we did a tangent. So, remember, wall's going up, right? Because this is an identity that we're having to verify. So let's think about this for a minute. 2 cotangent theta would be the same as 2 over this is a common mistake. A lot of people are going to take that 2 right there and pull it down as well. But then that would become 1/2. That 2 is not a 1/2, so don't send it downstairs. Now let's just use the tangent 2 theta formula. So this is going to be 2 over 2 tangent theta over I've been doing this since before you were born. Now, Big Kahuna shortcuts. I will be honest with you. If you can remember the u plus v and u minus v, which I've got strategies that I remember those with, then if I can't remember these, then I just go and do sine of theta plus theta and I figure out what it is. And that's just the honest truth. Now the sine of 2 theta is easy to remember. 2 sine theta cosine theta. I got that. The cosine of 2 theta, I sometimes forget if it's cosine squared theta minus sine squared theta, which one goes first. So I just write cosine of theta plus theta and I just work it out. The other ones I think are easy to remember, but I do think cosine of 2 theta and tangent to 2 theta, you got to think about those a little bit, and sometimes you may just have to go back and derive them again. Okay, let's see, what in the world do we got here? I'm dividing by this, which is the same as multiplying by the reciprocal good. So I'm going to go up here. So that's going to be 2 times Can we do anything there? I can do one thing real easy. Yeah, those 2's will cancel out, won't they? Because we're multiplying. Look at where we're trying to go. Those of you who play chess, you understand how to think a couple moves ahead. I stink at chess and checkers. I always get beat. I can't think ahead. My husband can think 3 and 4 moves ahead, and I can't do that. But look where we're trying to go. Do you notice that we're trying to get 2 separate terms? I don't have 2 separate terms in my denominator, but I do have a strategy. Let's go think about a strategy. No, think. Tell me what this is. 7/5. Tell me what this is. Do you see that if you have a single term in the denominator and a sum or difference in the numerator, I can do this, okay? And you're going to need to remember that, do that in calculus too, okay? So that's what I'm going to do over there. So what I've got is 1 over tangent theta minus tangent squared theta over tangent theta. Dun, 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 dun. Oh, look there. Look at there. Look where I'm trying to go. I got it, don't I? Because what is 1 over tangent theta? Cotangent theta minus that is where I was trying to go. I think we just have 2 problems left to do, eh? All right. Verify that that equation is a trig identity. Well, I bet you we're going to have to start on which side? Yeah, I'm probably going to start on the left. All right, sine 2 theta, sine 2x. Sine 2x. I know that one. Now, denominator, 1 minus. Now, this is where you got to really stop and think a bit, because I got 3 different options, don't I? Well, snap, which one do I want to use? Well, I don't know. Let's see here. Where am I trying to get? I'm trying to get to cotangent x. So I'm trying to make this thing end up being cosine x over sine x, right? Does that help us any? You think you want to use the sine one? The one with just sine in it? Yeah. Let's try it. Cosine of 2x. Now remember this, I'm subtracting it, so I got to do, is that it? You did it. That's the right one. Because now, what have I got here? I've got 2 sine x cosine x over what? That's just 2 sine squared x, isn't it? Because the 1 minus 1 will cancel. Whoops, I don't want to do that. So that'll be 1 minus 1, and then that'll be a plus 2 sine squared x. Ma'am?
Does it matter, so on the cosine squared, or cosine 2x, does it matter if it's like 1 plus 2 sine squared x? Like, does it matter
in the formulas?
So, like, when it's a regular cosine, so it's like cosine and then theta plus theta, it would be minus in the middle.
Yes.
Does this matter when
Wait, hang on a minute. What, okay, so what, yeah, no, I'm with you. So does what matter?
So, like, when you're doing cosine theta plus theta, it's a minus sign in the middle.
Yep.
But if you switch it, like, cosine theta minus theta, and it's a plus sign in the middle, so would the equation...
Now remember, my cosine 2 theta formulas come from cosine theta plus theta.
Okay.
Period.
It'd be that.
Yeah, yeah. Now, I think I got it because, and, so I get cosine x over sine x, which is, by golly, that's cotangent x, and that's what I wanted. Yep. How did I distribute? I took this right here, and I said 1, I distributed the negative, right? With me? Okay. Now, here's what you're thinking. Well, why can't I use one of the others if they're all the same? Let me show you. What if we decided, what if we didn't think about using that one? What if we decided we wanted to use another one? What if we decided we wanted to use cosine squared x minus sine squared x? Don't write this down. Then what would I have? Well, I'd have 2 sine x cosine x over 1 minus cosine squared x plus sine squared x. I can't do anything. Now, some of you might think, oh, there's cosine squared x plus sine squared x. No, there's not. That cosine squared x is negative. There's not a thing I can do. I am stuck. So that's when you say eraser. Hey, is, okay, so let's talk about that then. 2 sine x cosine x over, yeah, that's sine, yeah, let me back up then. You can do it this way, it will just take you extra steps. How's that? You can do it this way, it will just take you extra steps. So, yes, good point, good point. Okay. There are going to be some times when you truly will get stuck, where there's just flat out nothing you can do. And I just wasn't paying attention. Last one. Verify that the equation, bless you, sine of 4x equals 4 times sine of x times the cosine cubed x minus sine cubed x cosine x is a trig identity. Don't start with the right side, even though it's longer. We're going to start with the left side. You're like, well, I don't know how to do sine 4x because that's not sine of 2x. You got the right idea. You got the right idea. Here's what we're going to do. We're going to write 4x as, does that make sense? Now I want to show you something. So the sine of 4x could be the sine of 2x, and let me write it better. That's not written very well. The sine of 2x plus 2x. You with me there? Now I'm going to use my sine of u plus v formula. What am I going to substitute in for u? 2x. What am I going to substitute in for v? 2x. So this is going to be sine of the first cosine of the second plus cosine of the first sine of the second. What have I got? This and this are identical. So I got, perfect. So I got 2 of those. Oops. So far, so good. Now you're thinking, well, I'm not any closer to this mess here that I got to get. Well, yeah, you are. Do you notice in the stuff we're trying to get to, I have x, and then I have something cubed with x, but I don't have any 2x's, do I? I got to get rid of the 2x, and I'm going to do that by using the formulas that I already know. So here's what I'm going to do. First of all, let's get rid of that. I'm going to bring this 2 down. Now, what's the formula for sine of 2x? And then I'm going to bring this thing down. You could do this in one step. You could make a substitution for cosine 2x at the same time, but I'm doing it a step at a time to try to not get you goofed up. So what have I got now? Well, I got 4, right? Sine x cosine x times cosine of 2x. Well, here and here I just have x. That's good. But here I still got that confound 2x. That's not good. But notice right here, notice I got a 4. Didn't I want a 4? No, I wanted a 4 right here. So the 4 is good. Now notice what I want. I want sine x cosine cubed x, and then a sine cubed x and a cosine x. So the question is, what should I substitute here so that when I distribute this, because that's all multiplied, so I would distribute it all as one thing, that I could get that thing I'm looking for. First one, well, we'll try it. So 4 sine x cosine x times cosine squared x minus sine squared x. All right. Now remember, all of this is multiplied together, so I have to distribute it as one thing. It's like distributing 2x or distributing xy. If I multiply this times this, what do I get? 4. Yeah. Okay, so back. All right. When you distribute here, what do you get? 4 sine x cosine cubed x Is that what I was trying to get? Yep. You don't have to worry about factoring the 4 out. You got the same thing. Done. Ladies and gentlemen, those are the double angle formulas. So, shoot. Look how all the time you're going to have to work on your homework. Shoot. So, I'm going to talk to those of you who are watching the video. I'm going to talk to you for just a minute as soon as I get them started on their homework. Now, the quiz tomorrow, or next time, the quiz next time, I think it's quiz 13, is going to be a formula quiz. So, it might say sine 2 theta, and you would write down 2 sine theta cosine theta. If it says cosine 2 theta, it's going to have 3 spaces, and you're going to say cosine squared theta minus sine squared theta, and you're going to say 1 minus 2 sine squared theta, and you're going to say 2 cosine squared theta minus 1, and I hope I didn't mess those up. It could say sine, oops, that's not what I want to do. It could say cosecant theta equals, and you'd say it's 1 over sine theta. It could say cosine squared theta plus sine squared theta, and you'd say, well, that's 1. So it's just knowing your formulas. Okay, we're done. Bye.